Hello, welcome back to lecture. We're going to continue on hypothesis testing today. Before we were doing the mean for the last two sections, we were doing statements or hypothesis tests about the mean, about the population mean. In this section, we're going to be concerned about a statement about the population parameter proportion. So let's get started. So hypothesis test for population proportion, this is section 8.4. We're going to test a hypothesis about a proportion using the p-value method and then the critical value method. Where the structure is going to be the very same, even though we're doing something for a different parameter. The structure of the test, hypothesis testing, is always the same. We need to come up with a mathematical statement about a claim, do the complement version, assign H0 and H1. H0 always gets the equal sign out of those two statements. H1 tells us which test we're running, right-tailed, left-tailed, or two-tailed if it's a equal, not equal situation. And then we just do, if we're doing critical values, we do the regions by taking the critical value, and here's the regions. Rejection region is in the tails, fail to reject in the center. The p-value, we want to know the probability of it being more extreme. Right there, greater than if it's over in the right tail, less than if it's in the left tail, times 2 if it's a two-tail test. So everything's going to be the same. We'll introduce a new test statistic formula, and we'll just kind of go on from there. So in a recent Gen X2Z American college student survey, let me put me down here, 90% of female college students rated the social network site Facebook as cool. The other 10% rated it as lame. Assume that the survey was based on a sample of 500 students. A marketing executive at Facebook wants to advertise the site with the slogan, "More than 85% of female college students think Facebook is cool." Before launching the ad campaign, he wants to be confident that the slogan is true. Can he conclude that the proportion of female college students who think Facebook is cool is greater than 0.85? So he wants to give it a little leeway, but then he wants to make a statement, and we need to either approve or disapprove. So this is an example of a problem that calls for a hypothesis test about a population proportion. So this is categorical data. So here's the notation, a little bit of new notation for us. P is the population proportion. Sometimes this is the Greek letter pi is used for this, but P is what most of the books we use now. So P is the population proportion of individuals who are in a specified category. If we knew P, we wouldn't be doing hypothesis testing. Okay, so if we knew the population proportion, we know it, we would report it, there you go. We don't know what that population proportion is. All we have is sample data. So X is the number of individuals in the sample who are in the specified category. N is the sample size. And the p-hat, just like when we were doing confidence interval, p-hat was the center, our point estimate. Now it's our sample proportion. That's the same thing. The number of the sample who are in that specified category, and it's just X divided by N. Sometimes they will give you the p-hat. Here's the sample proportion. Sometimes they will say this many out of the sample. So in that case, we would have to calculate it. So here's some assumptions before we go forward with this thing, and this is, before we get started. We have to have a simple random sample that we have obtained the population or the sample proportion from. The population is at least 20 times as large as the sample. So we need a large population and then a sample, but the population has to be at least 20 times that. The items in the population are divided into two categories. It's either in the category or not in the category, basically. So you don't have any overlap. The values of NP0 and N times 1 minus P0 are both at least 10. The P0 is the value from your claim. So that comes from the claim. H0 comes from the claim. The quality version assigned to H0 is the P0. When I multiply n times p0 and n1 minus p0, the n, q0 are both at least 10. So here's our steps again, whether we're going to do the p-value method or critical, the first steps are the same. I state the null and alternative hypothesis. Actually, I need to start with a claim. I do a claim, a complement to get those statements correctly, assign H0 and H1 the alternate hypothesis. I need to have some significance level alpha. If I'm doing the p-value, I will use alpha directly to compare with the p-value. So I compute the p-value. If it's a left-tailed test from my alternate hypothesis, the p-value is the area to the left of z. The right tail, the p-value is the area to the right of z. Two-tailed, it is twice either one of those areas, to the left of negative z or to the right of the plus z. Our test statistic value, p hat, that's from our sample, minus p0, the value from the null hypothesis that we're using, and then divide that, p0, 1 minus p0, divide by n, take the square root of that computation. So do this first, and then take the square root. And these are z values, so it's the standard normal distribution that we are using to calculate critical values or the p-value. So this tells us, that symbol right there tells us whether we're going to use a t distribution or a z distribution for calculating p-values or critical values. That z says we're going to use the standard normal. Okay, and finally step 5 says interpret the p-value. If making a decision, reject H0 if the p-value is less than or equal to the significance level. We're always rejecting H0. We have to go back and reconcile what the claim was versus, the two hypothesis statements, H0 and H1, and then we'll make a conclusion about the statement itself. So let's get back to this and let's run this hypothesis test on this example. In a recent Gen X 2Z American college student survey, 90% of female college students rated the social network site Facebook as cool. Assume that the survey was based on a random sample of 500 students. A marketing executive at Facebook wants to advertise the site with the slogan, more than 85% of female college students think Facebook is cool. Can you conclude that the proportion of female college students who think Facebook is cool is greater than 0.85? Use the alpha equal 0.05 level of significance. So our first is we have to dig out the claim from this thing, and we're going to, the claim that we want to work on is that mu is greater than 0.85. So the p, the proportion, is greater than 0.85. So p greater than 0.85 is our claim. The complement would be p less than or equal to 0.85. Okay, so we can drop the less than to make it so we're just comparing it against the p equal. If we reject the equal, we've rejected all the less than as well. Okay, so here we're going to make sure that we've got all of our assumptions. Simple random sample of students. The size of the population of female college students is more than 20 times the sample size of 500. These are all the college students. The proportion specified by the null hypothesis is p0.85. Then 500 times 0.85 is greater than 10, that's 425. And then n times q0, the 1 minus p0, is equal to 75. That's greater than 10, so we can continue on. So here's our null. So we had the p greater than 0.85 versus p less than or equal to 0.85. That equality is assigned for H0. Our alternative is the H1. This tells us we're going to do a right tail test. The sample proportion p hat is 0.90. That was from our sample. So just because we have a sample, that doesn't mean the population proportion is greater than that, but it certainly supports that, but we want to make sure that we can't reject the possibility that we're close enough to 0.85 that would be it. So the test statistic of the z-score, here's the z-score, p hat minus p0, that's our test statistic formula. 0.90 was from our sample, 0.85 was our P0, divide by the square root of our sample. Actually, this is the difference between here and doing our confidence interval, is that this in a confidence interval, the standard error was the p hat, 1 minus p hat. This is, we're making a statement about the population. We think this is true. We're going to use that value. So when we do this calculation, we get 3.13. I'm going to do, this is a right tail test from H1. So I'm going to do the probability to the right of 3.13. So here's the normal CDF. If I use normal CDF, I calculate 3.13 to e to the 1 e to the 99. We talked about this in lab. 0 is the mean, 1 is the standard deviation, and it gives us an 8.74 e to the negative 4. So that's 8.74 times 10 to the negative 4, or 0.0008. Each time we have a negative 1, we would move the decimal place to the left. So that's certainly less than our test point of alpha at the 0.05 level or the 0.01 level we were testing. So we reject it at the 0.05 level, and what we rejected is less than or equal to 0.85 or 85%. So we can make that statement and we're good. Okay. Here's if we were using the TI-84, we can go through that. We do basically the same thing. This is the same slide, but here's the test that you would run on a TI-84. You would go and say, give me a one proportion z-test. That's it, a one variable proportion z-test. Enter all the values. Here's our P0. X was 450 out of the 500. We want to do a greater than P0 test. This is our statement that we wanted our right tail test. And then we just do the calculations. And our result would be that our P value, 8.7 e to the negative 4. So a critical value method, if we were doing the critical value method, we were doing basically the same thing. We're going to go through, but we need to do, from our significance level, we need to do critical values and build our regions. So let's go back through this. This one's different from what we did last time. A nationwide survey of working adults indicates that only 50% of them are satisfied with their jobs. The president of a large company believes that more than 50% of employees at his company are satisfied with their jobs. To test his belief, he surveys a random sample of 100 employees, and 54 of them report that they are satisfied with their jobs. Can he conclude that more than 50% of employees at the company are satisfied with their jobs? Use the alpha equal 0.05 level of significance. Okay. So we have a simple random sample from the population of employees. The sample size is n is equal to 100. Proportion P specified by H0 is 0.5. So our statements, so let's just do this. NP0 is 50, 1 minus P0, that's 50. So everything is good. The total number of companies is more than 2,000. Our sample was 100 employees, and we can do that as 100 times that. Bigger than the 2,000, that's the 20. Okay. So from our claim, we want to test that that P is greater than 50%. So P is greater than 0.5. The complement would be P less than or equal to 0.5. Then I would sign my H0, H1. H0 would go with the less than or equal to 0.5. H1 is my other one that doesn't have the equal. And this tells us, H1 tells us which test we're running, greater than the right tail test. Okay. So here's our critical value for this thing. We've done for alpha 0.05. At that alpha level, this was the critical region. The critical value was 1.645. So if I did go back, find the area in the table A3 to be 0.05 to the right or 0.95 to the left, that value would be 1.645, and that's where we get that. So now when I calculate my test statistic, p hat minus p0 was 0.54 minus 0.5, our p0 greater than 50%. Here's our standard error. That gives us a z-value for our test statistic as 0.80. I plot it. Here's our 0 right there at the hump. These are the positives, the negatives. Here's our 0.80. That lies in this fail to reject region. Fail to reject, rejection region in the tails. So we fail to reject H0. So it is possible that the true population proportion P would be 0.5 or less, somewhere less. Okay, it could be 0.49. But we reject we fail to reject that possibility all the way up to 0.5. So we can't really say that it's greater than 0.5. It could be 0.5 or less. Okay. So at the alpha 0.05 level, there is not enough evidence to conclude that the company president is correct in his belief that the proportion of employees who are satisfied with their jobs is greater than 0.5. And that's the critical value region. Okay. So go back through, read the section 8.3, 8.4, go back through the slides, work through them, make sure that you can do these calculations, set up the whole test, go through the claim complement, H0, H1, sit right-tailed, left-tailed, two-tailed, find the critical values, and then do the test statistic, and then determine if we fail to reject or reject H0. P-value, I always do the critical values, the critical regions method, and then I can go back and do the p-value on top of that just to have the p-value, but I've got everything laid out. I already know kind of where we're going with it, and if there's any mistakes I've made, it turns out to be obvious. Okay, so go back through those things. Hope you found this instructive. We'll see you next time. Have a good day.